Now, 30 days after it was launched, the James Webb Telescope has arrived at its final position in space. This $10 billion observatory has been parked a million miles from Earth. Engineers are now going to spend the next few months getting it ready to take images of the first stars to shine in the cosmos, no less. Well, Dr. Ken Kremer is a research scientist and space journalist and founder of the website Space UpClose and joins us now from Florida. Ken, thanks very much indeed for joining us. Well, it's got there. Why does it need to be precisely where it is?
Well, thank you for having me. Well, it needs to be there so that it can operate. A million miles, 1.5 million kilometers from Earth, needs to be far away so that it can be cool, because the instruments, which operate in the infrared spectrum, need to be extremely cold, just about 40 degrees above absolute zero. And they can only do that when they're out there at the L2 Lagrange point. That's a very stable orbit. And so it can stay there and operate for many years using minimum amount of fuel. So it blocks the sun also, for the most part. There's a little bit of sunlight that gets through for the solar panel, but most of it is blocked, and that way it can keep, as I said, extremely cold, because that's the only way the instruments can operate.
Right, that's interesting, and I'm sure you're dying for that to start, but I presume
Absolutely.
that takes a while nonetheless before they can actually put the telescope into operation, as it were.
It absolutely does. I saw the telescope myself about 5 years ago, where they were building it in NASA Goddard with the mirrors installed. But those mirrors are not functioning as one unit right now. They all have to be aligned. They were just released from the launch locks, moved about half an inch. And so now they're going to spend the next few months, about 3 months, aligning them. And then it's going to take about another month and a half to 2 months to get the instruments operating. So altogether, we got about 5 months or so till we see those first images. But the really dramatic part, the launch on Christmas, getting all getting it unfolded like origami, that's all done now, and it's in its park and orbit. So most of the risk is done.
Well, we're just seeing the pictures that you had of, in its state 2 or 3 years ago, so we get an idea as to what it's going to look like. Just if you can, in a nutshell, then explain what is the challenge now for this telescope? What's it got to do?
Well, what it's going to do is look back almost to the beginning of time, almost to the Big Bang, within 200 million years of the Big Bang. So we'll be able to see how the first stars and the first galaxies formed, which we don't know because Hubble can't go that far back. This goes further back than Hubble. The other thing we're going to be able to do is look at exoplanets, which are planets beyond our solar system. And we'll be able to basically search for life. We'll be able to look at their composition. We'll be able to look at their atmospheres, see if they have oxygen and water. And if they do, maybe we could find another Earth. So that's basically what we want to do. We also want to look within our solar system at moons like Europa, where there are geysers of water, maybe organic molecules, and see if there's other spots where there could be life within our solar system, not just at Mars, but some of the moons of Jupiter and Saturn and elsewhere.
Wow, it boggles the mind, Ken. Thank you so much for talking us through it, Dr. Ken Kremer.
Yeah, and those pictures of what it looked like, exactly. Thank you.
Thank you.